Alrighty then, let's take a look at real strange little examples. So we talked about primary key integrity, we talked about entities, we talked about attributes. We're going to go through a series of examples in this next sequence where we're going to take a look at all of these things. We're going to start paying attention to the details of attributes. Why? Well, that's a great question. About as good as why am I here? We're going to examine the details of how you might arrange attributes in a table, whether things can be broken up or not. Because the process you follow to make tables better is you break data apart and you organize it differently. This gets your database more effective, more efficient. In order to understand, well, how am I going to break this apart, you have to know, well, what's good and what's not good. So we're going to kind of go through and we're going to define what's good and what's not good, what are the names of things, and that's kind of the foundation we're laying. Then we're going to go up a level, and we're going to say, what makes a good table? How can we eliminate redundancy? How can we make things as simple as possible? Occam's razor says, make things as simple as possible, but no more simple than needed. And you as analysts, you as database people, have to find that balance between what's the simplest way to do this, what's the right way to do this. You get into these fuzzy areas, and that's where professional judgment comes in. The last thing we're going to end up with is we're going to talk about normalization, which is the process you follow to make a table good. Where does this all pay off for you? Well, frankly, we don't have an assignment for you to do database normalization. It's a pretty wonky topic. I'm sure in your database class they will cover database normalization. It's a little further into databases than we are able to actually have you do. It was probably 2 years into my career of actually using databases before I actually understood what normalization was, and I couldn't actually quote, well, I can't quote it for you now. Until I started teaching this class, I wasn't really clear on the difference between second form and third form. If you're a database wonk, you live normalization. So let's start building this thing up. Stay with me. You'll need this on the midterm. You'll need this in the curriculum. Memory is a difficult mistress.
You said this is up on this morning, right?
Yes, this is in your readings, and this PowerPoint presentation is there. If you haven't seen them already, I'm putting these silly videos up on the web.
Explorer doesn't like this thing.
You know how ugly I look? Well, you know how ugly I look. I don't discover how ugly I look until I watch these stupid videos. That's another story. That's just my problem.
Work with downloading anything from Google.
Yeah,
It's consistent.
Friends don't let friends use Internet Explorer.
Okay, so we'll let our web biases aside and look at entity integrity. Here is a wonderful little database table. It has a whole bunch of problems. This employee address field has got all sorts of problems. Way too much data in this column. We'll deal with that in a second. What's cool about this table is that every employee number is present and it's unique. So they're using this employee number as their primary key.
And so then the primary key goes into the next table.
Alright, so if somewhere I want to list, if I want to have a foreign key that points to employees, my foreign key, if I was talking about Georgette here, my foreign key would have 504 in it.
Okay. Like 504 and Georgia?
No, just 504. If I'm pointing at the employee table, the number 504 is all I need. Okay. So that, for all of its faults in the employee address column, it has a really cool primary key column. What a nice primary key column. Yes, sir?
Sir, what about the zero though?
I don't know what that 0 is. To me, I think this is where Access is saying, if you want to enter a new record, you click here, and it will assign a new primary key for you. If you set up your, normally in Access you set this field, you say this attribute is a primary key and it is not null and it's auto incremented. And then Access automatically chooses the next number for you. That's the way the database maintains entity integrity. It doesn't allow you to mess with that primary key field. It sets the primary key field.
Now, in a
Yes.
case like that where it's an employee number, can you override that so that you can put in whatever their employee number is?
As long as it's not duplicate.
Yes. So if you were upgrading, so let's say you were starting a business from scratch, and you were forming the business and you were employee number 1, you would make the database just generate the employee number for you. Okay, that rarely happens because we're constantly upgrading systems. So what typically happens is you've got this employee number and it has business rules associated with it, cannot be null, must be unique. But you've also got another primary key over here that just keeps this table intact. So if I'm upgrading a database and I'm swapping out some old database engine and I'm bringing in a new one, then yeah, at that point employee number is a primary key in the sense that it must still be unique. But I'll have to design the database so that I can enter that number myself. Okay, other questions about primary keys, entity integrity? Great, thank you. Cool. Now, foreign key integrity, referential integrity. This table refers to this table. That's why we call it referential integrity. You'll also notice that every one of these rows has an arrow coming out of it. Every row here points, every foreign key here points to some primary key here. Now, this is an example we'll carry around for the next couple of PowerPoints. This is an invoice table. So it's got a primary key, it's got an invoice number, it's got a date. Each invoice goes to a particular customer number. A customer number is probably a primary key in some customer table. The invoice has a certain amount of money that we're expecting to get from this person. It has tax stuff, it has other stuff, it has payment stuff. It has whatever the accounting department wants us to track for each invoice. The important thing here is that an invoice has multiple lines. So the business rule is invoices have one or many lines. You can probably visualize that the entity relationship diagram in your head. If not, I'll be happy to show you. So an invoice and a line, an invoice has one or many lines. And a line appears in one and only one invoice, as far as I know. How do they implement this relationship? They use this foreign key. The contents of this foreign key. Notice that the foreign key column has the same names here. I know there's some inconsistencies in our materials, but the thing I'd like you to know going forward, this should be the same name as this. It doesn't have to be. Almost every database engine will let you name things in all sorts of crazy ways. It'll help your head to remember that the foreign key is the same thing as the primary key in some other table. So these two lines are in one invoice. They have the same foreign key. They point to the same invoice. Every other line in this table is, well, here's two lines that go in the same, three lines go in the same invoice. Yes, sir?
In the sequel class that I took, we had to identify if it was a PK or FK, like in the title on
Okay.
So is that normal in the business
Yeah.
world, or is?
Yeah. A lot of, well, yeah, that's, well, it's a fashion that you see in a lot of places. Used to be, you used to put the type of variables in the names too. Again, if they say this is how we want you to name your primary keys, if every primary key has to have an underbar PK after it, then do it. Okay, so that's what it tends to look like. In your assignment, you need to set this up. usually you can right mouse click on this line, you can select this line, and you can bring up the properties of this line in Access-Elise, and you can see is referential integrity being adhered to. Now, one of the things that Access does that I find a little confusing is that it tries to be very helpful. So, when you're doing like an invoice table or a line table, and you have a foreign key relationship, sometimes it'll actually go look it up for you and put it in there. When you're first starting out, you can get confused by this. Because Access is being nice to you and actually going and getting the data and putting it in, it can look like the data is actually in the table. So be careful.
So,
Yes, sir.
excuse me, Al. So the line table is not complete though, because we don't have I mean, the foreign keys where the primary key should be, right? I mean, on the
Yes,
left
you're
there.
correct. Well,
But I mean, it's not.
there is no primary key shown in this table. That's right.
That's the foreign key with the foreign.
Yeah, it's foreign key, but do we have a prime, I mean.
No. This example should have a line number bar PK or a line ID or something like that.
Yeah.
So you're right. The line table here is not showing its own primary key.
Is that all right?
Well, it's obviously confusing to some people, and thank you for pointing that out.
It should have a primary key.
It should have a primary key.
Okay.
So in fact, although we have referential integrity in the system, we don't have entity integrity busted. Okay, hope you guys are all following that. Okay. So what he was saying is, see, this is a table. This first column is traditionally the primary key column. Well, in this table, there's no primary key. There's no line primary key shown. So, in a better example, I should fix this line and I should put a primary key somewhere in this table so that you can see that each one of these lines has its own primary key number. This slide has a problem. The first guy to report it gets a problem. No, hey, we found it together. Sorry. Maybe you should. Who knows? Get the feeling. I've heard just about enough about from you about the bugs in the system. I'm kidding, of course. All right. So remember that thing I said about how I didn't like that address? This employee address is an attribute. There's some problems here. Let's talk about this, the problems in this attribute column. So there's a couple different types of attribute types. There's simple and composite, and then intersecting that, there's single value, and there's multi-value. We'll talk a little bit about derived as well. Let's take a look at each one of these things. What you're looking for, if possible, is to have an attribute that only has one value. It's simple. It cannot be broken down into anything simple. It's atomic. So, for example, people's last names, that's why people tend to put hyphens in if they have Butler Smythe or something like that. You want that string to be one thing. Now, that's not true everywhere, but my name doesn't have any spaces in it, so my first name is as simple as it's going to get. Now, you might say to yourself, a big number can be broken down into different pieces. Like a big number typically has some sort of currency symbol, and then it has numerals, and it has separators, and then it has more numerals. At this level, what we're talking about today, it's just one thing. It's a price. It's a number. It's a floating point number. When I display it, I'll get fancy. In the database, I'm just going to store the price as a one thing. You can't break a number down into anything simpler. It's a thing. It's a set. It's a ton. Now, having said that, I can either have one value in that attribute or I can have several. What does that look like? You have to wonder if this guy lived in Portland. Anyway, it's a bad bad joke. Off-color joke.
Makes sense.
Typically, each one of us is only one gender at a time. I've been this gender my whole life, I don't plan on switching. If you were tracking a medical database, you may need to change this. But for those of us who are just tracking students, you declare a gender and I store it in the database. Now, in contrast, some people are such overachievers that they have more than one degree. I have a brother who has 4 of them. Drives me nuts. So, I've got to track all of those different degrees for that employee. So in one case, my attribute, the gender, just has one value at a time. It has a single value at a time. In some cases, the question of what's your degree has multiple values. I have a BS, I have an MS, I have a law degree, I have a medical degree, yada, yada, yada. My name is Roger. Anyway, so let's get back to that address. A composite attribute is something that I can break down into smaller pieces. And I should. I should break down composite attributes into smaller pieces. So I take this big long location, and it's pretty easy to break it down. We know what zip codes are, we know what states are. Now we know this stuff because we've been living in this country for a long time and we know how this works. When you're a business systems analyst, and it's not something as simple as a location, you have to understand the data to the point that you understand what the pieces are. I had a student tell me that these could be broken even further. The main street has to be different from east, and it has to be different from the address on it. In a well-designed city, that's true. If you were making a database, has anyone ever lived in England here? Yeah. So they've got the weirdest addresses. Hampshire House, Cambridge. And everybody knows where that dang place is. You don't need to give it a zip code or anything. It's been there since before time began, and everybody knows. Buckingham Palace. You can write Buckingham Palace, and the British postal system will get it there. If you're designing a database for addresses in Britain, it's different from here. That's why if you go on the web, you look at some websites that clearly have an international focus, and their address forms are much more interesting than ours. In this case, the designer has made the choice. I'm just going to break it down into the street address, city, state, and zip. Okay, so now I've got simple, I've got atomic, I've got single value, multi-value. Well, a composite attribute can be multi-valued as well. It's about as crazy as your brain's going to get today. So like we saw earlier, over the course of your career, you will have many addresses. And when you fill out some applications, they'll ask you for the last couple addresses so we can know whether you're a shiftless bum or whether you have roots in this community or whatever they're looking for. In which case, your employee address will have several values. Each one of those values will have several pieces. Okay? The main thing here is just figuring out what the names are. I mean, this is common sense stuff. I'm just putting names on these things. Multi-value, single value, composite, atomic.
What's atomic again? Just one?
Just one. Simple. Cannot be decomposed.
You mean it like, if there's one spreadsheet, it can't be decomposed into 3 of them? Is that what
And I'm saying in one cell, the data in that cell is as simple as it can be.
Okay, that makes sense.
So like if you were describing my head, you have hair color, you have beard, okay? You break it up and you have just one cell that was hair color.
Okay.
Alright, so now we've got our terms defined. We've got simple, composite, single value, multi-value. What's good? Ideally, you should get it to the point where everything's simple and everything's single value. Everything's simple and everything's single value. Why? Because it makes things easy to find, and it makes things easy for software to parse, to understand. So what you're doing is you're chopping and slicing your data up into pieces so that later on your software can pull it together and deal with it effectively. It may make no sense to you to have an address without a state, or an address without a zip code. But it'll make your life easier as a software designer to chop that data up. So then you can organize it by zip code, or you can organize it by state, whatever. If you have to use multi-valued attributes, you're setting yourself up for these kinds of problems. So, bottom line, head for simple, head for single value. I'm not gonna worry about all the different ways you can manage multi-value attributes, because I just told you not to do them. So, let's go forward. You notice PIM 1 in the assignment? PIM 1 had multi-value attributes. And they stored them in separate columns. And they were having trouble. And they broke it up into a different way of storing in PIM 2. So we have already seen in your assignment, the difference between PIM 1 and PIM 2 is it took these multi-value attributes, put them into single-value attributes. Okay. Now the main thing that you do with a multi-valued attribute is if you have multi-valued attributes, you tend to pull them out, put them in their own table. That's the main thing you do with it. In fact, you would spend a lot of time defining new tables. You'll find a pattern and you'll say, you know, I've got all this stuff in here, I'm just going to make a degree table. I'm going to pull all that stuff out, throw it in its own table, and connect them up with foreign keys. So that's what we do. It is not unusual to have lots and lots of tables. I think I told you this already. I have a simple application that we're building. And I showed it to the programmer, and then I showed him my analysis. And I think I have maybe 20 or 30 attributes of the stuff I want to store. And he said, this is okay. It shouldn't be more than 100 tables. And I was like, well, he says, well, this attribute's multi-value, this attribute's multi-value. I'm going to break those up into tables. And I found that over time, if I do zip codes like this and I do addresses like this, it's better to have 6 tables than to have 2. The guy just has a lot of experience. So he's automatically already thinking, oh, I'm going to break this data up. It's going to take more tables. So here's the example. We've got a many-to-many relationship between people and degrees. A person has 0 or many degrees. And lots of people have master's degrees. So and I suppose there's a degree somewhere in the world that has never gotten anyone, that no one has. But I don't think that exists for Rainer Schlemmer or something. Why am I saying this? Because I have one. To me, it doesn't make any, I don't want to track it if there's nobody who has one of those. Anyway, I've got this employee table. I've got the degree, when they got it, and what university they were at. This guy is my foreign key. Again, I'm not showing the primary keys in these tables. At least I'm not showing it here. And I'm not showing the primary key here either. This is the primary key of the employee table. If I want to know who got this degree in this year at this university, I use a foreign key, the employee number, and that goes up to there. Now what's tricky here is if you wanted to know, well, what does this stand for? This is actually being used as the primary key in this table. And all this table stores is the long name for that. So BBA, what does that stand for? Bachelor of Business Administration. This is actually a foreign key. So this is a situation where they're using the name of the degree as a foreign key and the degree code itself as the primary key. What's the problem with this? What's the potential problem with this? Well, you might, what does BS stand for? The content of this class. No. What did you say?
Bachelor's of Science.
Bachelor of Science? Could it stand for something else? Bachelor of Sociology? Did they make a degree like that? Yeah. What does MD stand for? PhD? Bottom line here is you are not guaranteed that this is going to be unique forever. This abbreviation might stand for two different strings. And at different schools, they might have a Bachelor of the Arts. Oh, it's not coming to mind. So although they are clearly using this degree code as a foreign key and the degree code as a primary key here, I think we might actually end up getting into trouble there. The concept is the same, though. The concept is the same. They used to have this table embedded in this table. They took out all of the information pertaining to the degrees and they pulled them out of the employee table. Lots of people got Bachelors of Arts in 1993 from the University of Kentucky. There's no reason to store that redundant data up here. They just factored it out and they put it in here. That's the process you go through all the time. You take data that's redundant, you factor it out, and throw it in a different table. I'm frankly not going to cover supertypes and subtypes.
What are nulls? Nulls are gamma.
Nulls are values in cells that indicate there's nothing here.
Oh, it's a point.
Yep. So this is a null, this is a null, this is a null, this is a null. In some databases, you'll actually see the word null there. But in this case, we're showing you as just a lot of space in the table. And remember, every time I got a cell that has nothing in it, I'm still storing something there. I'm still storing a null. Pretty soon you fill up your disk. So the way you manage this situation is you can eliminate some of these nulls by compacting and by splitting the data. Again, it's a way of improving the database by splitting the database up into two tables. In this case, we've got a company that has pilot licenses. In order to get a pilot license, you might have a, what does ATP stand for? Transport pilot. I forget what it stands for. In any case, in order to get a pilot's license, you have to have a medical, you have to pass a physical exam, and you have to pass a flight check. That's what gets you a pilot's license. Your pilot license expires if you go too long without another medical or you go too long without having someone reconfirm that you can fly. Well, not everybody in the company is a pilot. So some of these people have nulls in their lines because they don't need a medical, they don't have a flight check, so we got a lot of nulls. In fact, I would bet that most employees in a company, the company I had that had private jets, they only had 3 pilots. We had thousands of employees. So why don't we take all of this data, which is mostly null, and put it in its own table?
And just like backtrack the people out the licenses and put them in.
Right, so then for all the employees, now I've got a table that only has 2 columns, since most people don't have licenses. And then I have one table that has 4 columns that tells me the type of pilot's license the guy has, when he last passed his medical, when he last passed his flight check, and to tell me which employee we're talking about. I have a foreign key that points to the employee table.
And is 0 why is 0?
Again, this is an artifact of working in this particular database engine. If you click here, it would let you fill in this row, and it would assign a number. All right, we're going to stop here. What's the takeaway for today? The takeaway for today is there are lots of crazy names for stuff in databases, and you got to remember them all. You got to memorize them or know where to find them when it comes time for a quiz. You gotta remember what they are, because on Thursday, we're gonna talk about how do you make a good database. What goes into a good database? We've already started on that topic. You know, you don't have multi-valued attributes. The second thing we've seen is the process you use to make a good database. One of the tools in your quiver, in your, what is a base metaphor? One of the tools in your toolbox is you can take data in one table and you can pull it out and put it in its own table. So what you're going to do on Thursday is we're going to talk about normalization. We're going to talk about how, well, this is a problem. What do? Well, we pull that data out, we put it in its own table. Well, here's a problem. What do? Well, we pull that data out, we put it in its own table. We'll do that a couple of times. The other thing that's going to happen on Thursday is I'm only going to have about half of the time for lecture. The rest of the time, if you want to work on, get started on your assignments, you can. The next assignment is where you create queries, forms, and reports. We'll talk about what queries, forms, and reports are a little bit on Thursday. It is traditionally the toughest assignment we've got here, which is why you've got 2 weeks to get working on it. Why? Primarily because it requires you to learn Access to the point where you can create queries, forms, and reports. And I'm not going to help you on that. There are other people in this class that know Access. There are tutors in this school that know Access. Over at Sylvania, there are tutors that know Access. I don't know if the online office tutors can handle Access or not. Bottom line here is you're going to have to dig a little harder for this assignment than you have up to now. It gets easier to figure out, though. Good luck. See you Thursday.